In the next part of section 3.3, we're going to look at the sum and difference rule for differentiation. If both f of x and g of x are differentiable functions, and y equals the addition of f of x plus g of x, then y prime is the derivative of x plus the derivative of g. Similarly, if f and g are differentiable, and y is equal to f of x minus g of x, then y prime would be f prime of x minus g prime of x. So let's take a look at a few examples. Here we're asked to differentiate the following. Well, the first thing I need to do is I need to rewrite this, getting rid of my radical, making it a rational exponent. And now to take the derivative, the 4 comes out front. That would be 8x cubed plus 1/2 x to the minus 1/2. And depending on how they allow you to write your final answer, some books don't like to have a negative exponent. You can move that x to the 1/2 down to the bottom, and that would be your final answer. Just a little bit of math humor. Department of Geometry, of course, only angle parking is allowed. Next example, we're given a sum and difference of 4 terms, and we want to find the derivative. Again, it doesn't matter what the coefficient is. It can be a decimal, it could be a 5 pi, it could be anything. I bring the 4 out front, and that's going to be 9.2 x to the 3 minus 15 pi x squared. Whoops, I forgot the pi. 15 pi x squared minus 2. And there would be your final answer. Lots of people have trouble when it's just minus 2x and I'm asked to take the derivative. Well, remember the 1 comes out front and that drops down to a power of 0, and x to the 0 is 1, so you're going to be left with just a constant in front, which is minus 2. This example is a little trickier. So before we can take the derivative, root 3x is really root 3 times root x, times root x, plus 5, the cube root of x is really x to the 1/3, minus 4x plus 1, and now this is going to be x to the 1/2, 5x to the 1/3, minus 4x plus 1. So the first thing I need to do is get rid of the variables under the radical sign. Now I can take the derivative following the power rule, using the sum and difference rule as well. The 1/2 comes out front, so it would be 3 over 2, or root 3 over 2, x to the minus 1/2. I bring the 1/3 out front, it's going to be 5 over 3, x to the minus 2/3, and the derivative of negative 4x is negative 4. Now again, depending on how they let you write your final answer, they might move that 1/2 down to the bottom. Similarly, they might move the x to the 2/3 down to the bottom. Again, these two answers are the same, they're just written in a different form. Okay, in our next example, we're asked to find the derivative of a binomial squared. Okay, so the first thing you would do with this one is you would expand it. So again, x times x is going to give me x squared. X times negative 2 over root x is going to be negative 2x over root x. And multiplying these two terms with another negative x over root x. And that's going to be plus 4 over x. So if I simplify this before I take the derivative, I have 2x divided by x to the 1/2. So that's really going to be a 2x to the 1/2. Similarly, this will be a 2x to the 1/2. If I move this x up to the numerator, it becomes x to the minus 1. And now I'm going to collect like terms because I have like terms here. So I'm going to have x squared minus 4x to the 1/2 plus 4x to the minus 1. So this is still my function. I haven't done any derivative yet. Now when I take the derivative, the 2 comes out front, subtract 1 from the exponent. The 1/2 comes out front to become a 2. This becomes minus 1/2, and the negative 1 comes out front, and that becomes minus 2. And again, depending on how they let you write your final answer. And that would be your final answer without any negative exponents. In our last example, we're asked to find the equations of both lines that pass through the point 2,9 and are tangent to the parabola y equals 2x minus x squared. Well, first of all, it's always to graph y equals 2x minus x squared. I'm just going to factor an x out and create a table of values. So when x is 1, y is 1. When x is 0, y is 0. When x is 2, y is 0. So I'm going to get a parabola. Goes down something like this. And then I have a point 2,9, which is right there. And my question is asking me to find the equation of two tangent lines, because I'm going to have one tangent line coming from the left side of my parabola, one coming from the right side, that are passing through that point 2,9. Now, so let's just label that point. That point is 2,9. Now my points of tangency, I don't know what they are. I'm going to call them x, y. And now I'm going to try and find the slope of this tangent line first. So to find the slope, if you notice, I have 2 points on my tangent line. If I use this point of tangency in the point 2,9. So one way I could write the slope is, I could say the slope is going to equal y minus 9 over x minus 2. So I'm just finding the slope between these 2 points. And my function y is really 2x minus x squared. So in place of y, 2x minus x squared minus 9 over x minus 2. And that is one representation of the slope of the tangent line. Another way I could find the slope of the tangent line is to take the derivative of my original function, which would be 2 minus 2x. So now I have the derivative, which represents the slope of the tangent line, and I have this equation here, which represents the slope of the tangent line. So therefore, these two things must equal each other. Okay, so now I'm going to try to solve this equation. I'm going to multiply both sides by x minus 2, and distributing here I get 2x minus 2x squared minus 4 plus 4x equals 2x minus x squared minus 9. So now it's a quadratic equation. I'm going to bring everything over to the right-hand side. If I add 2x squared over to negative x squared, that becomes x squared. I have 6x, and if I add or subtract 6x over, I'm going to get minus 4x. And if I add 4 to negative 9, I'm going to get negative 5. So now this is a quadratic, which is quite easily factorable into x minus 5, x plus 1. So I have two x coordinates of tangency, x equals 5 or x equals negative 1. So I know that this should be really at 5. My point of tangency over here should be when x is negative 1. I really don't need to find the y coordinate of those points because all I need is the x coordinate to help me find the slope of that line. So now, to find the slope of the tangent lines, I'm going to call the first one tangent line 1 and this one tangent line 2. So to find the slope of tangent line 1, I'm going to use the derivative, which was 2 minus 2x, and I'm going to evaluate the derivative at 5. So my slope is going to be negative 8. And I have a point that the tangent line goes through, it's 2,9. So to find the equation of that tangent line, I'm going to use the slope formula. So y subtract 9 is going to be negative 8x plus 2. This will be negative 8x plus 16. And if I add 9 to the other side, I'm going to get negative 8x plus 25 would be the first equation of tangent line. And to find the second equation, I'm going to use the point x equals negative 1. So y prime at negative 1 is going to be 2 minus 2 times negative 1. I'm plugging it into the derivative. So y prime at negative 1 is going to be 2 plus 2, which is going to be 4. So again, I'm going to use the point slope formula. going to be y minus 9, it's going to be 4, x subtract 2. So y minus 9 is 4x minus 8. Y is going to be 4x minus 1. So those are going to be the two slopes of my tangent lines to my function y equals 2x minus x squared. Okay, so again, that question was hinging on the fact that you could find the slope of a tangent line by using a derivative and also by using our slope formula because we had two actual points on our tangent line as well. Okay, so there's the end of section 3.3 sum and difference rule. So there's an assignment from your Calc 30 text and from your AP text. So give those a try and see how you do.